All right, this is Unit 7, Lesson 1. This is the lesson that includes calculus. And one of the fundamental ideas of calculus is a limit. Let me use this function on the screen to kind of explain what the idea of a limit is. Okay, I'm interested in knowing what happens. So let me write this out. What happens around x equals 5. X equals 5. And actually, I'm going to change this to a plus, and I'm going to say around x equals negative 5. Okay. As you understand, or hopefully have deduced, if I let x equal negative 5, negative 5 plus 5 is 0, and we end up with a division by 0. So this function is indeterminate, right? It's undefined at x equals negative 5. So the question is, what happens around it? What happens near it? Okay. Let me pull up Desmos here to help make sense of this. So I'm going to call up Desmos. Oh, Desmos, Des least, not the Des least, but the Des most. And here we go, graphing calculator. All right, I'm going to use the table feature here. And I'm going to put in a value near 5. If I put in 5, it's not going to work here. So let's do this here. For the output, I'm going to do 2x1 cubed plus 9x1 squared minus 11x1 minus 30, all divided by x1 plus 5. There we go. Okay, and now I'm going to put in some values here. Okay, let's try something less than 5. How about 4.9? Okay, we get a value of 37.12. Okay, let's try a little closer. How about 4.99? I get 38.8102. Get a little closer, 4.999. 38.98102. 4.9999. 38.9981. You can see the numbers are kind of centering in on a value, right? If I try 5, whoops, I just realized something. I need to be doing negatives here. Negative 4.99. There we go. Negative 4.99. Negative 4.999. Negative 4.99. Okay, there we go. All right, and if I put in negative 5, undefined, right? Kind of what we expected here. In fact, let's go ahead and put in negative 5, and then we'll look at it from the other direction. So as we approach from the left, what value does it seem to be approaching? As you look at it, it seems to be approaching about 49, right? I can carry this on a little further here. Negative 4.99999. And as I continue to add 9s, it starts to oscillate, right? Oh, wow. Interesting results here. Okay. I think it's having some glitches there. All right, negative 5. Interesting. Okay, let's try it from the other side. Let's try something bigger than 5, or in this case, actually, less than 5. Negative 5.1. Right? 51.212. Negative 5.01. 49.202. Negative 5.001. 49.02, negative 5.0001, 49.024, 0021, negative 5.00001. Okay, both values seem to be approaching negative or 49 from the left and from the right. From the right, actually, because the numbers are negative. On the top, and then from the left, here, down here. Okay, and so this is a concept known as a limit. Okay, we say the limit as x approaches 5, negative 5, from the left, right? That negative sign means from the left, of f of x is 49, right? Bring it back up, Desmos. 49. We say the limit as x approaches negative 5 from the right is f of x equals 49. And we say the limit as x approaches negative 5, period, from the left and the right, seems to be an agreement at 49. Okay? And so let me identify some things here. The limit is what happens to the function as it approaches that value from the left, negative. This one is from the right. And this one is two-sided. We call it the two-sided limit. Now the two-sided limit only exists if the left and the right are in agreement. Let's look at it graphically. Okay. And let's zoom out here. And there's our function values right in there. Okay? And in fact, as we look at them, they're approaching this central value right here at at 49. Okay? In fact, if I graph the function, y equals 2x cubed plus 9x squared minus 11x, what was it, minus 30? Yeah, minus 30. All over, not all over, that all over, x plus 5. There's our function, right? Okay, but if you try to go right at 49, I had it there a minute, it's undefined. It's undefined when x equals negative 5. Okay, so let's see if we can figure out what that limit actually is. Right? Is it 49? It appears to be 49. It appears to be approaching 49 here, and it appears to be approaching 49 there. Okay, so let's treat this way here. We can manipulate the function a little bit, right? By division, by factoring the numerator. I'm going to use a little synthetic division here. I'm going to factor a x plus 5 out. So that in synthetic division, that means putting in a negative 5, writing the coefficients, 2, 9, negative 11, negative 30. Bring down, multiply, add, multiply, add, multiply, add. It ends with 0, so that was a factor. Okay, and I'm going to continue dividing here. I'm going to divide by x minus 2. So let's go here. Let's go 2. 2 times 2 is 4. 4 and negative 1 is 3. 2 times 3 is 6. So x minus 2 is a factor. So this is this. This is f of x equals x plus 5, x minus 2, and 2x plus 3. All over x plus 5. Okay? And you'll notice there's a common factor, and it does cancel out, with the caveat that x cannot equal negative 5. Okay? And so what's left is this. F of x equals x minus 2, 2x plus 3. again with the caveat that there's a hole at -5. All right, let's plug in -5. F of -5 is -5 minus 2. 2 times -5 is -10. -5 minus 2 is -7. -10 plus 3 is -7. Lo and behold, it is 49. Okay. So a couple of concepts here. We couldn't directly plug in -5 to the original function because it was indeterminate. And so when you can, direct substitution, we call that direct substitution, is the best method. But very often, direct substitution is not possible because it's indeterminate. It results in division by 0. And so we need to examine what happens around it. One of the big ideas of a limit is limits don't care what the function value is at a, right? Where we're defining that as the limit as x approaches a of f of x. Okay, we don't care what the function value is at a, we care what the function value is as we approach a, as we get closer and closer and closer to a, but without actually arriving at it. All right, and so a couple of little review items. A left-hand limit is what does it do as it approaches from the left? A right-hand limit, what does it do as it approaches from the right? A two-sided limit only exists if the left and the right limits agree. By the way, there's a hole here at the value x equals -5, but the function, the limit doesn't care what that value is at -5, just what it does as it approaches. You can use a table to approximate, to figure out what a limit is. Just put in closer and closer values from the left and from the right of the value in question, right? And then, and just be aware that in Desmos, when you add too many digits, it starts misbehaving. Then you can also figure it out algebraically, if it's a rational expression, by simplifying or canceling out a common factor in the numerator and the denominator to eliminate the hole. We call that a removable discontinuity, if you recall. Though you don't actually remove it, but and then you can direct substitute at that point. All right, so I think that's it. That's a limit. Now that's my limit.